Mr. Willis, last day of school of lecture, page 129, section 5.3. Turn in your books and listen to me. I'm a poet and I don't realize it.
Huh?
Taylor, Bennett, EGF, Hogan, Drew, Jay, Tucker.
I'm filming. I'm in the book.
Open your book, Leah. Page 129.
This is that's my book.
Give me my damn book, bro.
Graham, Jay.
What page was it again? What page? 129.
What page?
129.
You're so funny to be mean to.
Because
it's like, you make I'm just kidding, not in this. So my brain's dead. I think they are like really hard to we can never tell now. What? Because I'm little.
Okay.
So nasty.
No, Tucker, stop. He's reading.
You can have this one.
All right, quiet down, please.
What's that?
Quiet down, please. Up here.
What's up?
You guys still don't have your books out.
I do.
As we talked about yesterday. Page 129. Section 5.3. As we talked about yesterday, you have different types of countries in the world. Your more developed countries and your less developed countries. More developed countries are like in the United States, the countries in Europe. The less developed countries are like India, Mexico. The poorer nations of the world.
Mexico's pretty
The
developed.
population problem is mostly due to the less developed countries. We see 78% of the population growth is there. However, at the same time, the more developed countries are responsible for a lot of the world's pollutions and wastes. You can see the more developed countries produce 90% of the hazardous wastes. The more developed countries consume 60% of the fossil fuels. The more developed countries consume 80% of the metals and 75% of the paper. So although the population problem is not ours, the consumption problem is ours. And this bodes for problems worldwide when some of these less developed countries, especially with the big populations, start becoming more developed like we are. You can see there's just not going to be enough stuff to go around. So this section talks about some of the solutions to these problems, which we need to pay attention to. First of all, we need to define a few things. Renewable resources refer to resources that are replaced by natural processes faster than they're consumed. We call those renewable resources. Solar power is a renewable resource. We have lots and lots of sun hitting the Earth, which just bounces off and goes back into outer space. We aren't using all the resources we can. You use up some solar power, and more comes right away.
Unless it's cloudy.
That's true. That's a good point. Unless it's cloudy. Wind is another one.
When it's nighttime.
Nighttime too. But there will always be another day. There will always be times when it clears up. You can get more solar power. And there's lots that we don't use. Wind is the same way. Winds will always come. There are some days when it's not windy, but there will be more wind. One source of renewable resources is, you've heard of ethanol from crop production. You grow corn or something like that, scientists can have the ability in the lab to convert that to fuel.
Fuel.
That's correct. Fuel does not have to come from oil. It can be made from crops that are renewable, meaning after you cut these, you can grow new ones. Wood can be a renewable resource if it's used correctly. One way that this is done is, if you have a large enough parcel of land, think about a huge plot of land. Not working very well. Try a different one. A huge plot of land. Now, it might take 30 years to grow pine trees big enough where you can cut them and cultivate them and sell them for wood products. But you have a big enough parcel of land and you divide it into groups. 5, 6, 7, 8, 9, 10. Okay, I got 10 groups here. 10 groups of trees. I didn't make them exactly the same, my mistake. But let's pretend they're all about the same size. Oh no, wait, I would need 3 if it's 30 years. Okay. Every 2 years we cut a group of trees. We cut this group, and then after we cut it, we sell all that for wood products, and then we replant it. It's going to take 30 years for that group to grow. So, now that group is growing back, and we cut the next plot. Plant it, and it'll grow back. 2 years later, we cut the next plot. 2 years later, we cut the next plot. 2 years later, we cut the next plot. If you count, there's 15 plots here. After you get to the end, you can go back and cut this one again. Because it's been 30 years since you cut it, and it's all grown back. And if you keep going through and just cut a plot every 2 years, you can keep doing that. It will renew itself.
You do it to more than one source.
Yes, Graham.
Yeah, I guess that makes sense. But wouldn't you smell like... Never mind. This is dumb.
So, here's the problem.
You are smart.
Listen. Here's the problem.
Why don't you just clear cut it and wait 30 years and do it again?
This requires a lot of area. To keep a constant supply of wood for the country, it requires a lot of area. Because you can only use a little bit of it at a time if you want a constant supply. If you cut it all at once, you're not going to have a constant supply.
But in 30 years, you will.
It's difficult to have that much land. The problem is when you have so many people that they need more wood than this single plot can supply. So that's when if you cut it all, it can become a non-renewable resource if you run out of space and start making the land into, shopping centers and roads and such. You can run out of space. Now, your non-renewable resources are limited in limited amounts and are replaced by natural processes over extremely long periods of time. Now, an example of that is oil, coal, uranium, metals like aluminum and such, lead. These things are taken from the ground and taken from the earth, and they don't really renew themselves. It takes oil millions and millions of years to form. And we've pulled, some estimates are half of the oil out of the ground in just a couple hundred years. So that means a couple hundred years, there'll be no oil left. But factor into that the population is going up so fast, it'll be a lot less than a couple hundred years. Factor into that a lot of these countries like China are moving from bicycles, which everybody used to ride, to automobiles, and consuming a lot more than they used to. We could run out of oil very quickly. So non-renewable resources you can run out of, and that will happen. Graham? Are you sure?
What if they invent some kind of machine to clone oil They can clone used tubs of
Unfortunately,
oil.
there's no machine like that.
Well, they can make it in the future in 50 years.
Bro, are they like, do they have any advances in like alternatives? Once we run out of oil, do they know what we're gonna do?
Yeah, that's what we're working. That's what you hear is working on right now. Okay, the people that are talking that don't have their hands up are interfering here. Okay. That's what we're going to talk about. What can we do? You know, after you run out of oil, you know that we're getting low on it when it's $3 a gallon or close to that, and that'll just go up as fuel runs out. So one thing that they're doing now is they're going to try to run cars off of electricity. You've heard of hybrids and plug-in hybrids. That's using more and more electricity. And coming out at the end of this year, our cars called plug-in hybrids basically kind of works like a golf cart does. You take a plug and you plug it into your wall socket and you charge the car off of electricity.
Electricity costs, you have to make it with coal.
Wait a second. Now, let me wait for that to quit ringing.
Why don't you pick it up?
You just pick it up and hang it up.
Now,
That's rude. Or change the number.
listen. Most electricity is also made from non-renewable resources like coal. But here's the thing. Coal is a lot more plentiful than oil. And it's also, we have a lot of coal in America. We have to import most of our oil. So right now it would be a lot cheaper if you could run your car off electricity produced from coal. And hold on, you don't have your hand up. Again, you're blurting stuff out. Now, so right now the projections look like this. If you spend, let's say, $100 a month on gas, running the same car off of electricity, your electric bill would probably go up about $30 a month. So it'd be a lot cheaper right now if we did have plug-in hybrids to plug it into the socket. Even though we're burning coal to do that, it's a lot cheaper and a lot more efficient. The power plants produce electricity a lot cheaper than with coal than power produced in an internal combustion engine with oil. Just a second, let me say one more thing on this. One thing that would help is if we moved to making our power off of something besides coal. If we made it off of solar or wind or nuclear power.
Steam.
They're building a lot of nuclear power plants.
Steam
now,
power.
A lot of those, hold on, you haven't raised your hand either.
Sorry.
A lot of these are in the works, building nuclear plants. That would help some too. It's just expensive to build wind and solar and nuclear power plants. You need a lot of money to do that, and money is in short supply. So this is something we're going to have to move to in the future. It's going to take a while to convert, but as coal and oil and that stuff becomes more scarce in the future, we're going to have to do it. There is no alternative. Yes, Graham. Did I answer it?
Yeah.
I was hoping I would do it. Yeah.
What kind of fuel do hybrids use? Like Priuses and stuff?
They use gas.
What kind of gas?
And the gasoline, just
regular
regular gas. And how they work is when you step on your brakes in a Prius, it charges the batteries a little bit.
What do you mean?
Batteries?
Batteries?
You have batteries
Car
in your car.
battery. Oh.
Yeah, your car batteries. So they have these big batteries in those cars, and every time you step on your brake, it charges them up a little bit, and it makes it more fuel efficient. That's what the hybrids now. That's how the hybrids now work. You use less gas. But that's different than the plug-in hybrids that will charge your battery from the wall. That will add a lot of extra mileage to your car that way. Yes, Bennett.
Chevrolet's coming out with a car that's electric, solar power, and runs on gas.
Yeah, the Volt.
Yeah. Volt.
Yeah.
Used to look really cool. Now it looks cool.
Yeah. It used to look like a Camaro.
Other questions?
No, actually.
So in my lifetime, I've seen gas go from 75 cents a gallon to $3, and that's about 4 times the cost. So when you reach my age, if it continues at that pace, it'll be $12 a gallon. That's a lot.
Well, I'm kind of making sure. I'll ride it back.
Now, what else can we do to help protect the biodiversity of the planet? Well, we can set aside land that we protect and that we do not disturb. Taylor, up here.
Yes, sir.
And we call these wildlife preserves or national parks. About 7% of the world has been set aside as a national park or some sort of preserve. And you can see here in blue all of the different national parks in the country. Now, there are also a lot of state parks that aren't listed on here. You know, like Stone Mountain State Park in Atlanta, that's not on here. And Jekyll Island is one. Yes, Graham.
I've been to Acadia National Park
In Maine?
I can't. It's a cool place.
Graham, do you want to go stop?
What?
There's only one national park in all of Texas.
Okay.
A couple there. Now, all right, listen. The biggest one we have in America is Yellowstone National Park. Well, and then there's some in Alaska that are actually bigger than that. But in the continental U.S. is Yellowstone. National parks are important. A lot of these places have a lot of stuff on them, like wood, that could be used. But once you do that, you start affecting the biodiversity, and so to preserve that, we need to try to preserve these national parks. Also, just for vacationing, that sort of thing, it's a big monetary boost for the country and states that have these things. There's a lot of tourism dollars. So, in a lot of ways, the national parks, pay for themselves. Even though we're not using the land for growing things and harvesting trees, you're making money off the tourism aspect. So you need to preserve that as well as you can. Now, there are areas on the planet called biodiversity hotspots. Areas that have a lot of biodiversity, but are quickly losing it. Kind of like the rainforest I talked about earlier, that have lots of wilderness and different species, but it's being cut down for farmland. And this little video on that, we call it a biodiversity hotspot when it's got a lot of wilderness, but it's in danger.
Around the world that have exceptional levels of endemic species and critical levels of habitat loss. Endemic species are only found in specific geographic areas. Biodiversity hotspots, which are highlighted in red on the map, are ecosystems where endemic species are threatened. To be called a hotspot, a region must meet two criteria. First, there must be at least 1,500 species of vascular plants that are endemic. Second, the region must have lost at least 70% of its original habitat. Approximately half of all plant and animal species are found in hotspots. These hotspots originally covered 15.7% of Earth's surface. However, only about 1/10 of that habitat remains. If these endemic species become extinct, biodiversity will decrease.
Look on page, everybody turn to page 132. It shows a bunch of these different biodiversity hotspots.
Same map on the video.
Yep.
Almost.
These are areas that scientists are very interested in. And areas where we think it's a good idea to put in money to preserving, because if those areas go, you lose lots and lots of species. And so scientists are trying to preserve these certain parts.
We're trying to preserve Cuba?
The wildlife there, yeah. Rapidly going extinct. Remember, islands are one of the locations that you lose a lot of can lose a lot of organisms quickly. Now, one of the things about the world right now is that the habitats are being fragmented, being cut into pieces. And a fragment of habitat doesn't support nearly as the species of a larger area. So one thing scientists are trying to do is connect the fragments together. And you can do that with what we call habitat corridors. You can see, here's a fragment of forest here. And whoever developed the area with, you can see there's some farmland, but they have left, this is called a habitat corridor, so that organisms can move from this fragment through this area here to another fragment that's further down that they're not showing. And you can see these little lines of trees. It's not much, but it's enough that organisms can move from one area to the other without, going over the open land, which is dangerous for organisms, and lots of organisms just won't do it. And so if you run out of resources in this little fragment, you can go somewhere else. And that seems to really help species. Yeah. Yes. This is a habitat corridor that goes over a road. And roads are a big part of all societies today, and they serve to fragment areas. If you have a road passing through the woods, you have fragmented that area into this area and this area with the road in between. Lots of organisms can't pass over roads. You see they get hit by cars. Some of them will just not go out into the open. And so to keep places like that from being fragmented, these corridors can be built. That is kind of a grassy area that goes over the road. Yes, Graham? This is a neat graph. This shows the recovery time for various disruptions. On the bottom of the graph is the size of the area that's affected, and on the side of the graph is how long it takes to recover. The basic rule of thumb is the larger the size of the area that's affected, the longer it takes to recover. This is in years here. So lightning might strike an area and it just takes a couple of years for the area to come back. A meteor strike, 10 to the 4th years, that's 10,000 years.
100,000.
So meteor strike is very disruptive. But look at some other things. Volcanic eruption. It might take several hundred years for a place to come back from a volcanic eruption. When I was y'all's age, I was exactly your age, a big volcano went off in northeastern United States, Mount St. Helens. And the area is still not recovered. It knocked down a lot of trees and that sort of thing.
Is that northwestern United States, like up in Washington State?
Yeah, Washington State.
You said northeast.
I said northeast? I meant northwest.
What's
Yes.
slash and burn?
It didn't say.
Slash and burn is what they've done to the where is that?
Rainforest, west side.
Rainforest. Oh, here we go. That's when the people come in, they want to plant crops, so they slash the forest, and then the trees that have fallen, they burn them, usually in big pits. And that clears the forest out so that they can plant agriculture. And that would obviously take a long time to recover because the trees got to grow back. Yeah.
Never mind. Never mind.
So the oil spill, it says oil spill.
Isn't 10 to the 4th
We have a big oil spill going on.
We got a big oil spill going on. What happens in an oil spill is all that oil washes up on the shoreline. It damages organisms living on the shoreline, and that damage might last 20, 30, 40 years. Again, when I was about y'all's age, actually I was in college, there was a huge oil spill off the coast of Alaska. It's called the Exxon Valdez.
I remember that.
The ship ran aground. The captain of the ship happened to be drinking. the ship ran into some coral reef or something like that. All the oil spilled out. It ran up on the shoreline, and it still hasn't recovered
What
completely.
about that huge oil spill that's going on now? That they're
Yeah.
going to wipe out the huge.
This oil spill is so big going on now that they estimate that it's about an Exxon Valdez disaster, which was the biggest one before now, every 4 days until they get that thing capped.
Because isn't it supposed to wipe out the whole, like our whole side
No, it's not
up to
even
Maine?
It's in the
like,
Gulf.
Yeah, but apparently they said it's going to
It's
like
gonna come
keep
around?
going.
Yeah, it's not true.
I don't know about that.
I was watching it on the news and apparently it's just like.
You sound like you're
trying to answer the
Yeah, this is probably the biggest oil disaster in the history of.
Is this gonna make oil prices
Yes.
go up?
Yes, please do.
Is this gonna make oil prices go up, bro?
It probably won't affect oil prices that much, because one oil well doesn't produce that much oil. The consumption of oil is so much greater than one
Wasn't that the
well.
biggest one in the Gulf?
It may have been, but all the Gulf wells only contribute less than 1% of the oil.
How do
Much
you
less.
how do they get it capped?
I don't know. Tried to drop something over, but it didn't work. Yeah.
A couple of days ago, there was a big thing about like a BP oil well that they're gonna like shut down because they built it wrong. It wasn't like eco-friendly.
I hadn't heard about
I
that.
heard that they were losing like something like billions of dollars a day.
I heard that you were
on
wrong.
Sure. Oil's expensive. So the best way is to not have these problems is to not use oil, obviously. This is called bioremediation. One thing you can do to clean up things like oil spills is you can spray bacteria onto the oil and the bacteria eat the oil up. And they eat it up and they multiply and they give off the toxins, tear up the oil and make it back into carbon dioxide, which floats up in the atmosphere. But you don't have all the oil all over the rocks. We call that bioremediation when the organisms fix the environment. Yes?
Why are they wearing yellow suits?
There's oil all over the place. I don't want to get oil all
Did you
over.
not see the video we watched yesterday? No.
Yes.
You said it's all over the rocks. Like with that chemical, or bacteria, could we drop a bunch of that bacteria in the ocean?
Or
Yeah. Unfortunately, it's not that easy to spread around. You can't just drop it in an area and the stuff moves. You have to spread it all over.
What if we spill
That's why they use those sprayers.
We just use the ocean as oil. That could work. That could work.
No, everything's living.
Use the ocean as well.
Yeah, just drain that.
One thing that we can do to help solve some problems is called biological augmentation. One thing you can do, for instance, to control the aphid population is add ladybugs to the area.
What is an aphid?
Ladybugs, hold on, let me finish talking. Ladybugs eat aphids. And aphids are a big problem for farmers because aphids eat the crops, but ladybugs eat the aphids and ladybugs do not eat the crops. So we call this type of solution to some of our problems biological augmentation. It's very tricky. You never know what a high ladybug population is going to do to an area. It might affect the food chain. Perhaps ladybugs eat other things other than aphids that are helpful. These types of solutions are tricky. Sometimes they work and sometimes they backfire and can cause problems. But you may hear about things like
What
that.
are aphids?
Aphids are these little tiny bugs that eat crops.
I mean, what kind of, like, I've never heard of them before.
Now you've heard of them. They're little tiny insects.
Are they just little, like, highlighter yellow things?
Yeah, they're not all yellow. Some of them are different colors, but yeah. Little tiny bugs that eat crops. Okay, so that's it. You
We're
guys
done.
were just terrible today.
Wait, we were terrible.
Yeah, you guys were not good. Talking a lot, not paying attention, laughing. I'm gonna have to make this next test really hard.
Do it.
For those people. So we're finished. You need to read 5.3 tonight. There could be a quiz on that tomorrow. We have a lab tomorrow.
What's the lab?
Biology Thursday, test Friday, and then we review next week. And then you have your exam. The lab is going to be a rat dissect.
I love that.
We're going to cut up a rat and look at its
Are
parts.
you sure it's a rat, not a mouse?
It's a rat.
What is it?
Ratus, ratus.
Or a mat.
Everybody
What's
tell me
outside?
which one of you my partner.
There it is.
It's outside.
Do it. Did you read them?
Oh, I will not be your partner for the.
I know. I use
I'm Grace. I'm Grace.
Like, no, now you can see me. Hi.
Don't do it. Don't do it. Don't.